adders, for half adder, full adder, subtractors. Yes, non-standard pos and sop. If we have done questions for from this topic, that they are also included. Okay. Okay, the next will be the half adder, full adder. I think we have done the standards conversion of SOP to POS and POS to SOP also. Is it so? No, the K mapping of POS is not included. K mapping of POS, we haven't done the K mapping of POS. Okay. Okay, should we continue? Yes, obviously, all the topics that are before mid are also included. Boolean function using mux is also not included. Okay, I think we will move on with the topic wise. So the next will be the half adder, full adder, parallel adder. Okay, half adder, full adder, then subtractors, parallel adders, look ahead carry adder. These all are included. Okay, we haven't done one's complement adder or subtractor. Okay, so after this, we have the decoder, mux, demux, encoders, and priority encoders are also included. Okay, priority encoders, basically encoders and priority encoders were not included in the mid, but this time obviously we have these topics and especially the priority encoders. Okay, low priority encoder, high priority encoder. We have these questions in CLO2 based. Okay, of around 5 marks. For all these decoder, mux, demux, encoder, priority encoder, again, you all have to start from the truth table, expression, and then diagram as well. Okay. For some of these circuits, we have drawn the only the block diagram instead of the whole combinational gate-wise gate diagram. We have drawn some block diagram. So you can also use that block diagram. Okay. For mux demux, if we have I think we have drawn the mux demux with the block diagram, so you can also use that block diagram as well. Okay, but if anything is mentioned in the question paper, okay, you have to use this method or you have to uh, solve this question using these steps, so you all have to follow those these instructions. Yes, Aisha. 7 segment, obviously. 7 segment. For 7 segment, you have to use the block diagram. Okay. Just connect A, B, C, D, E, F, G with the proper connections instead of making the gate level diagram. Yes, if 16:1, so you have to use block diagram. But for the smaller sizes, you have to implement it using the gate level diagram. Okay. So all these topics are before the mid, except the prior encoder and priority encoder. So every topic before the mid are also included. Okay. So after the mid, we have only three to four major topics, and these are first we have again for the some of the topics are part of the combinational, that is encoder and priority encoder was a part of combinational. Magnitude comparator that we have done after the mid is also a part of a combinational section. Okay, in magnitude comparator we have compared two numbers, their diagrams, their expressions, all things are included. Okay, so after the magnitude comparator we have the sequential part of your subject, all the combinational logic and the basic introduction done. Is this clear to everyone? Yes. Please, all of you, join the class on time. Yes, I Sayyid Ali, the magnitude comparator, most significant bit and least significant bit. Can you please elaborate your question? No, we will not skip 16 by 4. If we have one question, then we can easily convert it to its larger version as well. They are not difficult. They all are related. They all are on the same pattern. Yes, I will, Mariam. For magnitude comparator, we have done only one one question. That is basically for comparator. That basically compared two numbers, either it be greater or less or equals to. Okay, we have done only one thing. Cascading is not included. Any type of cascading from any topic is not included. I'm repeating it. Cascading from any topic is not included. Okay. So after the so coming to the sequential logic, in sequential logic, starting from the basic sequential combinational comparison or differences, we have the synchronous, asynchronous circuits as well. Then we have flip-flops and latches. Acha, in latches we have done only the SR latch. SR latch because it's the simplest and we will use it. And we have done it with the NAND implementation and NOR implementation as well. Okay. So after the flip-flop and latch and for flip-flop, we have covered all the four types of flip-flop, their purpose. Timing diagram is also not included. Okay, except the counter one that we have done in our online class. Okay, the timing diagrams, the cascading, pause, K mapping, NAND NOR implementation, these are not included. Okay. Yes, all the theories included. Theory means their definitions, their comparisons, their differences. Okay. Asna, about which topic? I'm repeating: cascading, timing diagrams, pause scheme mapping, and the NAND NOR implementation, active NAND NOR implementation. Okay. Cascading, NAND NOR implementation, one's complement adder subtractor, pause K mapping. These things are not included. Timing diagrams for counters obviously included. Okay. I will share the whole topic list by tomorrow on GCR as well. Okay, the after the latches and flips, in latches we have simply done the most simplest one, that is SR with the latch with the NAND and NOR implementation. Okay, in flip flops we have covered all the four types of flip flop. Yes, Aisha. No, they are included. NAND NOR implementation is basically another topic, and that was before the mid. Okay. Okay, the logic diagrams for flip-flops, their logic diagrams, their symbols, their characteristic table, their excitation table, all everything from the flip-flop topics that we have covered are included. Okay. I'm repeating again, NAND NOR implementation means the topic that was before the mid and we haven't covered in class. Obviously, when we haven't covered this, so you will not know about that topic. So it's not a part. Okay, Ali. So after this, we have the synchronous count latches and flip flops. Then we have the synchronous counters, asynchronous counters. Synchronous asynchronous counters may both counters are included along with their state diagram, their working table, that is basically for count sequence, and then finally their diagrams and their expressions. Okay. Then we have shift registers. Just for registers, I have shared a document with you for counters, for sequential logic, and then for registers, and then for state diagram. I have shared the documents for these topics. You can follow these topics, and other, the examples that we have done in class for these topics are also included. Okay. So in shift registers, all types of shift registers plus the universal shift register. Then we have the last topic. Second last topic is basically the state machines, that is the finite state machine. Okay, Uni, after this topic list. So in finite state machines, we have two types, Murray and Mealy. What is basically a finite state machine? What is Murray, Mealy? How we convert the diagram into a table or table into a diagram? How we can identify from the given state diagram that which one is the Murray, which one is the Mealy, what's the difference? All these things are included in this topic. Okay. If you have some input sequence, then apply that input sequence in a particular from the starting from the particular state. All these things are included. Okay. So after this, the last topic is the designing of sequential circuits, in which we have to follow all those steps, starting from the problem statement. If problem statement is not given, if you have directly the state diagram, then you have to start from the state diagram. Then we have to follow each step, because each step has marks. Okay. If you skip any part, obviously your marks will be deducted. So from state diagram, then you have state table, then you have to draw the reference table that you are using, which type of flip flop. Okay. Reference table, then you have the excitation table, then flip flop input functions. After the flip flop input functions, for flip flop input functions, you have to clearly draw all the k maps for each variable. Okay. Then after this, we have the sequential circuit, designing of sequential circuit. Okay. All these things are included. Okay. One more thing is the difference between switches and relays. We haven't covered that topic in our class because it's not that much important, but I want all of you to simply uh, just take it as a reading assignment, or just simply the difference between the switches and relays. Okay. Their types, their working principle is not included. I will also share a PDF document in which you have the difference between switches and relays. Okay. Only take it as a reading assignment, just difference between switches and relays. The working principle, their types, or anything else is not a part of that topic. Okay. Is this clear to all of you about switches and relays? Just have a look on the difference of what is switch in between switches and relays. Okay. Is this clear to all of you? It might comes in a 2-mark question. Is this clear? Yes, Aisha, if we are given only the problem statement, yes, if the problem statement is given, then you have to draw the state diagram. And from the problem that problem statement is basically to be converted into a diagram. Okay. If you have to take any assumption like from which state to another state, so you can take it, but I think the problem statement is will clearly define all the transitions as well. Okay. How many differences are enough? If there are if you have a 2-mark question, then obviously the 2 differences are enough. If you have 2.5 mark, then you have to write 3 at least. The whole counter topic, or any one, or any particular example? Sanya, were you not in the class when we have discussed this topic? Okay, okay. In asynchronous, yes, why? I think we haven't derived the expression for JK when we connected them to the high. For the asynchronous mod counter, I think we have not derived the expressions. We directly from the diagram, from the working table, we directly come to the diagram. Okay, from the state diagram, then working table, and we directly draw the diagram. Yes, Spike, is it clear to you? Please recheck the lesson. We haven't drawn the expressions for J and K while working on the mod counter. We directly, yes, we directly came to the diagram. Yes, Aisha, can you please repeat your question? Yes, transitions are given. Okay. To the counter to make it a negative edge triggering synchronous counter. For negative edge triggering counter, we just have to, if you are talking about the diagram, we just have to show a bubble on the clock diagram, and we have to take the clock from the previous true variable. Okay, for the true variable, for negative edge, we will take the clock from the previous true variable, and for the negative positive edge triggering, we will take the clock from the complemented variable. This is the case for asynchronous. And if you are talking about a synchronous, then for synchronous, we have the clock pulse that is from the external signal. So there will be no changes in the diagram, except that we have to show a bubble on the clock pulse, on the symbol of a clock in the diagram. Okay, all the clock pulses are from the outside. Counters are obviously a part of a sequential circuit. It might come separately, or it might come with the designing of sequential circuit. Both things are same, Asna. 2-bit synchronous up down counter, or a counter with a sequential. There is no difference in these two things. In 2-bit synchronous up down counter, if it's written 2-bit synchronous up down counter, then you have to follow it. If this problem statement is given, then you have to follow all the steps for the designing of sequential circuit. Is this your question? You can check the marks for that particular question, obviously, if it's of 7 marks around, let's say. So you have to complete it using all the steps, or if it, or I think it should be written in the question that design a sequential circuit for a 2-bit synchronous up down counter. The question should be like this: design a 2-bit synchronous up down counter. Okay, design a sequential circuit that is for 2-bit synchronous up down counter, and use any type of flip flop. So the question should be like this, and the mark should be obviously around 7 or 6 or 7. Then you have to follow all these steps. But if it's of 4 marks and it's just written design a 2-bit synchronous counter, then you can follow directly the state diagram, then its working table, and then the steps that we have done for that question. Is this clear? Yes, Maria. Why do we label counters as up down? If the counter is mentioned as a up counter, so you up counter means 2-bit synchronous counter in a increasing sequence. I have many times I have repeat these words, up counter, down counter. Or in the last class we have also drawn the up and down counters in a single state diagram as well. Can you explain when to draw preset and clear in diagram? You can draw preset and clear in every sequential diagram. Okay, preset and clear are just the asynchronous inputs of the flip flop. We can draw it any diagram, but we will use it only in the mod counter. We can just show the pin, we can just label it two inputs with the preset and clear, but we are using it only in the mod counters. Is this clear to 5 or everyone? Yes, a counter can be an up and down. When we have a question like design a up and down counter, then in last class, if you all have that lesson, I have drawn a diagram of up and down counter. For up and down counter, I have to when we will convert that counter into a diagram state table, then we have either x equals to 0 or x equals to 1. We have two columns. Okay, then all the up sequence will come into an up x equals to 1, 0, 0, and all the down sequence will be in the x equals to 1. This totally depends on the state diagram. So how you have drawn the diagram, you will convert that diagram into a table. I have repeatedly told these things in the class. So why you all are so worried about these things? Yes, I will share, Hans, after the class, or by tomorrow I will share the list of topics and some more things. Yes, unique counter can be up and down, but depending on the value of input, you can follow one input, let's say x equals to 0 for defining up sequence, and you can consider uh, x equals to 1 for defining down sequence. If it's not mentioned in the diagram, you can use any input for defining any sequence. It's up to you. Or if it's mentioned that x equals to 0 for the up sequence, then use this, and x equals to 1 for the down sequence, then you can use this. Okay, I will also share some counters questions as on GCR before the exam, so you can practice it more. Yes, yes, Aisha. In a positive or negative, if the clock is low or high, this depends. If you are working on a positive edge trigger, then it will work only when the clock is high. On low clock, it will not work. Okay, and for the negative edge trigger, it will work only when your clock is low. If it's high, then it will not work. Is this clear to Aisha? Drawing preset and clear is not necessary. If you want, you can draw it. If you don't want, you cannot, you will not. Okay, but it's necessary in the mod counters diagram. State diagram, once or twice means state diagram. Obviously, you have to draw diagram only one. You have to keep track of your time as well. The LDST paper is obviously a lengthy one. You all have to keep track of the time as well. Okay, Aisha, I will explain it. Yes, it's important. I will explain it. I will share that picture and then I will explain it. But before this, I have to take an assignment from all of you. So I'm sharing a link on a GCR. Okay. Only this 7194 is left or any other query. And the one from the COD is about counters. Okay. These two queries are left. Yes. Yes, Asna. Acha. Yes, Asna, your answer is yes. And Hans, the steps are starting from the sequential circuit problem statement. You have the problem statement or you have the state diagram given. Hans, Aisha and Bakhtiar, for you, the problem statement is must be given. Okay. If the question has the state diagram, I will convert it or I will write a description in the form of a problem statement from the diagram. And you both, you all three have to start from the problem statement. Okay. You can, I will write the diagram in terms of a problem statement. Okay. So you will start from the explanation of a state diagram and then you have to start from the state table, then excitation table, then function flip-flop input functions, and then after flip-flop input functions you have the instead of designing of sequential circuit, you just explain your diagram, you explain the connections of your diagram in the form of a paragraph, as you did in the mid. Okay. How to prove there is, why you have to prove it? Aisha, are you talking about the tracing of inputs? Okay. Okay, I will take a session for the CODs. I will announce on a GCR. Okay, in the next week, I will take a lesson for all CODs for explaining the counters. And I will announce it on GCR. Okay, I will explain the 7194, but these two, after these two assignments. Okay, so all of you, I think you all are cleared with your queries. Yes, is it so? Please don't get panic. It's very easy. Everything we have already done in the class. All topics are very easy. And you have a lot of practice problems in your questions as well, in your lessons as well. We have the different variations of each question. So you can attempt that question as your practice problem. Okay. So quickly, we have. Okay. The third step of sequential circuit, Hans, is the excitation table. The first step is the problem statement or state table. Okay. The second is convert state diagram. The first is problem statement or state diagram. The second is the state table. Third will be converting that state table into an excitation table. When we are converting state table into excitation table, let's say if we have, let's say, two states in our state table, then excitation table has four states.
Miss, am I audible?
Yes, yes.
एक्सेशन टेबल नहीं उसके बाद फ्लिप डॉट फंक्शंस वो एक्सप्लेन कर रहा है.
अच्छा, फ्लिप फ्लॉप इनपुट फंक्शंस में for flip-flop input functions, we have to check the current state of, let's if we are working on, let's say, SR flip-flop, we have two flip-flops A and B. So I have to check the present state of A with the next state of A. Okay, the first column of A, that is from present state, will be compared with the next column of A, that is for next state. Okay, then we will check if both are 0 0 0 1 1 0 1 1. So we will complete that table with respect to the reference table of SR. Is this clear to you and all of you? I will compare every present state of A with the next state of A, and then I will fill the SA column accordingly. And similarly, the RA for A, then we will fill the RA column as well. Is this clear? Hans, is this clear to you? Similarly, for if we are working on the flip-flop B, then I have to check the column of present state, column of the for the present state of B with the column of the next state of B. Then I will check two B's. One is from the present state and one is from the next state. Okay, depending on these present and next, either it be 0 0 0 1 1 0 1 1. I will check my reference table and then fill my SBRB accordingly. Is this clear again? Okay. Achha, those who practiced well, for those it's easy, obviously. I have also heard we haven't done any example or we haven't done any practice problems in class. So this is not the right thing. We have already done so many questions in our class, in our lessons, and again we have so many practice questions for each topic. For every topic, we have the practice problems that are little different from the one that we have already done in the class. Okay? Is this clear to everyone? Are you all clear with the topic list? Acha, the last thing about that is the paper pattern. I have already told this in my last class. Those who were present, they are very much familiar with the paper pattern. And those who were not present, why they were not present. Okay? So the last thing is, quickly we have two things. Okay, I'm sharing a link for a Kahoot. We have 55 students. Kahoot is simply an online game that has simply 8 questions in it. I'm sharing a link. You all have to join that link using the uh, ID that I'm sharing. Okay, you all have to join. When all of you join that quiz, then I will start this quiz. Okay, I will start the quiz. You all have to wait. When everyone join, then it will start. Okay, acha, first thing this. The second thing is, you all have to join with your name, first name, and with your roll number. Write your name. For example, for Hans Raj, it's Hans slash 179. Okay, 179 is your roll number, Hans. Am I right? So, okay, you have 30 seconds for answer each question. After 30 seconds, the quiz will automatically jump to the second question. Are you all ready? This quiz or this Kahoot quiz is just for the practice. It will not be graded for anyone. Okay. The quiz that I will share after the Kahoot, that will be graded for those who have missed anything. Is this clear to everyone? This quiz is just for practice. Okay. This will not be graded. Is this clear to all of you? Yes, I have shared a link. Okay, Aisha, so no, it's not necessary for everyone. If you are, if you have done all assignments, all quiz, then there is no need to attempt it. Okay. Acha, I have shared a link. Kahoot ID and the game bin is 3395267. You all have to join it quickly with the name and with your roll number. Okay. Quickly join. Okay, this quiz is just a class activity for reinforcement of the latches and flip-flops. Okay, this is just a reinforcement activity for latches and flip-flop. This activity will not be graded. Okay, is it clear to everyone? Please join the game with your name and with your roll number. Please don't write the complete roll number, just write. So we have 35 students, but in the class we have 56. The rest of you, please quickly join it. Okay, Mariam. For sectional criteria, we have the mid of 20 marks. Then we have an assignment of 10 marks and one quiz is of 10 marks. So in this way, we have 40 marks we have already done. Those who have missed any assignment or quiz, for them, there is an assignment that is in the form of a Google form that I will share after this quiz. They all need to submit it. Okay. And this quiz that I'm taking right now is just a reinforcement from the topic flip-flop and ledges. So I'm going to start it. Are you all ready? Quickly, thumbs up. Okay, anyone still left to join? Yes. Yes, Asna. Acha, one more thing for all of you. Please don't take lessons from other sections. The topics, the examples, or anything that we have done in class are enough for all of you. Okay. For section A and D, for section A and D, you all have the topics, lessons that we have done are available with you. Yes, Safa? Limit reached. Okay, so I should start it. The rest of you will join it later on. Okay, so I'm starting this. You all have to read the question and answer it within 30 seconds. Okay, so you all are done with, I think 10 to 12 students were are still left. So it's just an activity for all of you, fun-filled activity. I think it's for you. Okay. So the rest of you who were not able to join, I will share these questions with you. Okay. No problem, Hans. No, there will be no chance of redo because, okay, good. So I will share these questions in the form of a Google Doc on GCR. You can later on you can check these questions. Okay. Obviously, they will not be graded. If anyone missed these questions in the Kahoot, so it's not a big issue. Okay. Okay. So all of you, there are 54 students. Now I am sharing a Google form link on GCR. Uh, Sayyida, Farwa, Rizvi, and the rest of you. I am sharing a link on a GCR for the assignment that will be graded. You all have to attempt it. So I will take best of two. Is it clear to all? I will take the best of two. One you have already done and the one that you are going to do. Okay? Are you all ready? We have 55 students. I'm sharing a link for a Google form. Okay, you all have to attempt this assignment within 10 minutes. 1 minute for each 1 minute for each question. You have total 10 questions. 1 minute for each question. I'm sharing it at 11:10. So I will not take any responses after 11:20. Okay. I have shared this link. Quickly join the link and start solving. Turn in. I will not take any response after 11:20. Okay, or I will not grade the responses that I have after 11:20. Start. All of you, you may start it. Are you all doing this? Quickly thumbs up. Yes, it's from the topic registers. I have shared this link. I have shared the link in the chat box. Hasnan, do you have it? You have 10 questions. quickly answer it, and then submit your assignment. Yes, it will be graded. Yes, it will be graded. I will take best of 2 for those who have already attempted the earlier quiz or assignment. And for those who have missed any assignment, obviously this is the only one that will be graded. Okay? So all of you quickly complete this. Good. I have received 28 responses. Class, quickly complete this. Yes, it will be graded. I have already told you it will be graded for all. It will be graded for all, and I will pick the best of two for those who have already done their assignments or quiz. But for those who have missed any assignment or quiz, this is the only one that will be graded. Okay. Yes, there is no field for name and roll number. You all have to just sign in with. You all have to write your email ID. Have you written your email ID, Hans? Yes, cloud ID or any other ID. Okay. Yes, I will upload the sessional